Hi, I'm William Bush, the Field CTO for Europe at Catalogic Software. And today here, I'm going to run through our recipe for CloudCasa and getting it deployed on a Rafay managed cluster. So we can see here, I've got a cluster already imported here, running on Amazon EKS, as we can see, and I've got a kubectl prompt as well sat here. So this cluster is running 1.20. We can protect resource data for any cluster running 1.13 and above. And we can also protect persistent volumes for any cluster running 1.17 and above. Also, we need Helm version 3 installed on the workstation or deployment system, and also kubectl also for accessing the cluster from a CLI as well, which we've obviously got here within the Rafay platform. So the first part of the recipe and the first step we're going to take is adding the Helm chart to the repository. So if we scroll down and if we go into integrations and we go into the repositories here, we're going to select that we want to add a new repository in here. So we can call that CloudCasa repo. This obviously within here is going to be a type of Helm. So we create that. We see here now we have to specify the endpoint where that Helm chart exists. So this is HTTPS. So we can see here then that's the settings that we need to find within there. So we see the bottom here. So we can see now that repository has been successfully. So the next step, and step 2 within the recipe, is then subsequently creating an add-on. So with this, we need to be logged in again to the project as we are here as an org admin or infrastructure admin. So if we go into infrastructure and go into namespaces, and we're going to create a namespace in here. We call this default. So we're going to create that within here. So let's just create that namespace there. So subsequently to that, we're now going to go and create the add-on. So if we go into add-ons, we select new add-on, we have to bring our own, and if we input here, call it CloudCasa 1, Helm v3, we're going to pull the files from the repository type is Helm, and the namespace is the one we've just created there, which is default-CloudCasa. So that straight away there has created the add-on. Now we need to add a version in here. So the version name here, we will call it v2.0.0, which is the most recent version of the CloudCasa agent. Repository here, we will drop down and go from the CloudCasa repo. And subsequently in here, the repository chart name will input as CloudCasa and the chart version as v2.0.0. So you can see here now that has added our add-on within here now. So subsequently to that, what we're going to do now is we're going to go and create a blueprint. So we go to blueprints, we select a new blueprint within here, and we call this CloudCasa blueprint. It's going to create a blueprint in here. Subsequently to this, we need to again add a new version in here. So we're going to call this again v2.0.0 within here. And under add-ons in here, what we want to do is add more on the add-on. We can see here, we can dynamically see that add-on that we have just created. And we can also select the version from that there as expected. So that's added the version into the blueprint. It shows in here the component add-on, and effectively is what is then going to enable the deployment of this subsequently. So if we go back up to the cluster, and let me just show you the cluster itself here. So we've got this, it's Kubernetes version 1.20. If we go into the workloads here, we can see we've already done, obviously, the deployment of the default blueprint from Rafay. So we've already got some of the workloads we'd expect within here from Rafay on their Rafay-infra and Rafay-system namespaces. What I'm going to do now is I'm going to come in and I'm going to select in here that I want to update the blueprint. So if I come into here and I select the CloudCasa blueprint, And I select our version here and select save and publish. That's going to publish the blueprint and subsequently install the CloudCasa agent on our selected cluster. That's now ready. There's a few other managed system add-ons that we've already done that are actually now redeploying and rechecking through there. If we go into EKS now, and if we just select refresh on there, what we should see in a moment is we should see that we have an added workload on here for CloudCasa. So yeah, here we can see the Cube agent in the CloudCasa-IO namespace has just been created a few seconds ago and successfully deployed via that blueprint. So we now have the CloudCasa agent successfully deployed. So that's step 4 complete. That's effectively all we need to do in terms of the integration and what we do within the Rafay management console. Subsequent to this, what needs to happen is users need to go on step 5 and set up a CloudCasa account by going to cloudcasa.io, going to the login page and selecting sign up, inputting their email address, the password they want, their first name, last name, company, and job title within there. Once they've done that, they will subsequently be able to log into the CloudCasa portal within here. And we can see here, if we select on protection and we select on add new cluster, we can add a new cluster in here. So it's very simple to add a cluster. All we need to do is input the name, which here we'll call Rafay-CC. We'll input a description. We will select register cluster. You can see here then we've got a kubectl command to basically deploy the manifest file with the .yaml and just enable the communication here to take place. So if we go back into our specific Rafay environment, and if we jump back onto the cluster, we go into kubectl, I'll connect into our cluster. As we can see, that has now been successfully configured there, and the communication is now set up. So if we go back into CloudCasa, we can see that cluster is now as expected in an active state. We've got the cluster ID, we've got the description, we've got the provider, and our version of Kubernetes that is running, which is as expected 1.20. So from here now, what we can do is we can easily set up backup policies and define backups. So if I select define backup here, and if I call this test, we select our cluster, we can add optional tags as well if we want to. We've got the selection here now to do the full cluster or specific namespaces. So we can see here the namespaces that exist on this specific cluster. I'm going to select full cluster. We can also select specific labels if labels are associated with any of the namespaces within here. We can, by default, we include persistent volumes. For the purpose of the demo here, I'm going to untick that. So we just do the resource metadata. And again, we can do snapshot only, or we can snapshot and we can copy to the CloudCasa infrastructure that is available in terms of storage within AWS and Azure. Again, here, I'll select just snapshot only. We can then add a new policy. So with the policy, it's very simplistic to do again. We simply have a name, the time zone, and then how frequently you want the backup to run, be that hourly, daily, weekly, monthly, or on a custom basis within here. And that'll then set you the timescales within here and also your retention period. And you can then add that to the schedule to create yourselves a new policy. For the purpose of the demo, I'm just going to select none and run this manually. So if I select run now on here, that'll retain that backup for 7 days. So we can see in here, we jump into backups. We'll see there the last 3 runs. But we'll see what we have here is we have 1 running in progress. So we're going to the activity log. So that's going to straight away initiate the backup process and back up the relevant resources that have been selected via this backup job. So we can see there straight away, we've got 7 namespaces protected in here in terms of the resource metadata, and that backup there has been successful as expected. What we can also do from here is we can run restores. So if I was to select restore on here, You can see here our recovery point for the backup that we've just run. In here, we've got the ability in terms of selecting the relevant resource that we want to restore. We can do all protected namespace, or we can do individual namespaces from here and select the specific namespace we want to restore. Again, we can also select labels, and we can choose if we exclude or include persistent volumes as part of this within here. So let's just do Rafay Infra as the selected namespace to restore. Call this Rafay-cc-. We'll go back to the original destination here. Obviously, with the power of this as well, if we were to add additional clusters in here and we wanted to restore namespaces to alternate clusters, we could do that within here as well. And you've also got the option, if you don't want to overwrite, to do a rename on here as well. Select restore now. That's going to successfully kick off that restore. If we go into the activity, we can see the restore as expected is running. And if we jump into the activity log, that restore is now in progress, and those resources that have been selected are now being recovered. And there we go. That restore has been successful. So that's CloudCasa. As you can see, it's very, very quick and easy to get this deployed via Rafay. That's really is all there is to it. You can sit back, relax, know your cluster is protected, and utilize CloudCasa to do this with our software as a service offering to protect Kubernetes cluster resources and also cloud relational databases as well. Thanks for watching, and yeah, talk to you all again soon. Cheers.